Hello and welcome to today's video. In today's video, I want us to discuss chemical kinetics, which is rates of chemical reactions. And in this video, we are going to focus on what we call the rate law. And we're going to discuss how to determine the rate law. So what is rate law? So basically, rate law means this is just a mathematical expression that shows the relationship between rate and concentration of the reactant. So rate law is just an expression that shows the relationship between rate and the concentration of the reactant. So usually this is expressed as rate is equal to K A then N. That is for a reaction which has only A and produces products. So in this expression, we have to understand what the variables mean. So K represents what is known as the rate constant. Then A, in this case, represents the concentration of the reactants. Then N represents the order of the reaction. Now, this is an expression for an equation which is in this manner. Now, if the equation was to be A plus B giving us products, in this case, the rate law would have been K A N then B M, where N and M represents the order of reaction. So to determine the overall order of reaction, we add N plus M. This is a second scenario. A third scenario is where we have A plus B plus C giving us the product. So in this case, the rate law can be expressed as K, then A, let's say N, B, M, then C, P. Meaning, to find the overall order of reaction, we'll add N plus M plus B. Now, for us to look at rate law or to determine rate law, there are certain important conditions that we need to observe or respect. And one of those conditions are that Rate law only deals with reactants and not products. Then the other condition is that the N, which is the order of reaction, is determined experimentally. So you can only determine the N or the M or the P by performing an experiment. Now I want us to quickly go into the questions on how to determine the rate law. So we have questions of this nature. So to determine the rate law, like I mentioned, we perform experiments. So experiments will start as the initial concentration of A for experiment 1, experiment 2, experiment 3, and then we'll keep changing the concentrations and we'll be obtaining the different initial rates. So to determine the overall reaction order, this is how we go about it. So what we do is we'll say rate of experiment 2, which is given by K. In this we have initial A and initial B, so this is N, then B will be M. Then rate 2, which is over rate 1, again is going to be K, the initial concentration of A by N, then B M. So what we're doing here is to find these exponential values. We are using these two experiments, so experiment 1 and experiment 2. So we're going to key in the variables. So this, for experiment 2, our rate is 2.70 times 10 to the power negative 7. Obviously you have to be consistent with the units, so mole per liter second divided by 1.35 times 10 negative 7 mole per liter upon second is equal to, so we have our K, then the concentration for initial concentration for 1 is 0.100, so I'll use molarity in this case, and then for B I shouldn't forget the the superscript 0.0, then this is M divided by K. So for rate 1 again is 0.100 N, then for rate 2 is rate 1 initial concentration of B is 0.005. So you have to be consistent with the units. So here what happens is this and this will cancel. Then when you do the math, when this is calculated, it gives us 2.0. Then this side we equally get 2.0, then M. Therefore, when we do the math, same base, meaning M is equal to 1. So we know the value of M. Then to determine the value of N, we're going to use rate. So this will be rate 3 divided by rate 2. So rate 3, if we key in the values, is going to be K, then 0.200 molarity, N, then 0.01. Let me write this properly. 10 molarity M, then divided by, for 2 is going to be, that is for 3, then for rate 2 it's going to be 0.100 N, then 0.010 molarity, then M. So here we realize that this and this will cancel, then the K and this will cancel. Then here when we key in the figures, obviously it means that rate 2 is 5.40 times 10 with the units, of course, mole L seconds, then that divided by rate 2 is 2.0 times 10 negative 7 mole. So this comes down to 0.200 molarity N, then 0.100 N. So this gives us a 2.0 when we punch, then this gives us a 2.0 N. Therefore it means that our N is equal to 1. So to find the overall reaction order, so it's N plus M, so it's 1 plus 1, meaning the order for this reaction is 2. Then B, the question requires us to find the rate constant. So to find the rate constant, we can just pick one reaction. Well, we say rate, maybe rate 1 for the first experiment. It's going to be K, then the concentration of A, N, then B, M. So here we know that N, M both are equal to 1. So to find the constant, it means that we are dividing by those concentrations. So we are dividing by those concentrations, B, M. So that will be out. So to find the constant, we just pick one stream, the first one. So our rate is 1.3. Let me just confirm. 1.35. 1.35 times 10 negative 7 mole per liter second. Then we key in the concentrations for the first experiment. So our initial here is 0.100, so raised to the power 1. Then this one is 0.005, again raised to the power 1. You have to be consistent with the units, so when that is done, we are supposed to get something like a 2.7 times 10 to the power negative 4. This is liter, then S. Yeah. So that is how we find the rate law. This is how we determine the rate law. We can look at the second question, where we are given 3 concentrations. So in this case, to determine the rate law. So we state the formula where we say rate is equal to K. So we have A, N, we have B, M, and we have C, P. So how do we determine for the first one, how do we determine the overall reaction order? So what we can do here is we can say rate 2 divided by rate 1 is equal to, so K, we can B, that is M, then C, P, then K, A, N, B, M, and C, P. So now we can slot in the figures. So we are looking at this and this. So rate 2 divided by rate 1. So this gives us 8.0 times 10 to the power negative 4. Be consistent with the units. Then 1.6 times 10 to the power negative 3. That is in this case. So this gives us K. So rate 2 is 0.2. This is N. Then 0.10. This is M. Then 0.10. This is P. Then divided by K. The first experiment will have 0.10. This is N. 0.10. This is M. Then 0.10. This is P. So we notice that this and this will cancel, that and that will cancel. So this translates into, when we do the math, this gives us a 2.0, then this into that 2.0, then N. So in this case our N is 1. So we know N. Then we'll continue. So to continue, we'll say rate 3 against rate 2. So here we're going to key in the values, and what we're going to get is, this is 3.2 times 10 negative 3 divided by 1.6 times 10 to the power negative 3. Then experiment 3, we have a 0.20, that is N, then 0.20, that is M, then 0.10, that is P. Remember there's a K here, divided by, there's a K down there. So we are on experiment 2, which starts with a 0.20 N, then 0.10 M, then the P 0.10 P. So here this and this will cancel, this and this will cancel, the K and the K will go. When we do the math here, this gives us a 2.0, then this gives us a 2.0 M, which means that our M is also 1. Then for the last one, is going to be rate 4 divided by rate 1. So this is the only combination that will help us to find B. So when we look at 4, this is 3.2 times 10 to the power negative 3 divided by rate 1, which is 8.0 times 10 to the power negative 4. Then we'll say K. For rate 4 we have a 0.10 N, 0.10 M, then 0.20 P. Then experiment 1 gives us a 0.1, that is on N. Again, it gives us a 0.10 on M, then a 0.10 on P. So these and these will cancel, that and that will cancel, the K and the K will go. So when we do the math here, this gives us 4.0. Then the other side we get the 2.0 P. So here when we do the math, it's the same as 2 raised to the power 2, then 2 P. Therefore, our P is equal to 2. So for the reaction order, so overall reaction order, it's N plus M plus P. So 1 plus 1 plus 2, which gives us a 4 as a reaction order. Then for the last one, to find B, to find the rate, so we can just pick the first reaction, say rate 1, which is going to be divided by A, N, then B, M, C, P. Then that will give us the K. Therefore K, if we pick the first reaction, this will be 8.0 times 10 to the power negative 4. If we put the units, this becomes more this S divided by, putting in the concentrations, so 0.10 raised to the power 1. Just to confirm, 0.10 raised to the power 1, then 0.10 raised to the power 2, and this should give you something like 8.0 L3 3.s seconds. Alright, see you in the next video.